Hello viewers, this is Dhanalakshmi from R Engineering College. Let us discuss now about 180-degree conduction mode of inverter. Since we know already about inverter, which is going to convert DC to AC, and in which PWM inverters will work in two different modes, 180-degree conduction mode and 120-degree conduction mode. And now let us discuss about 180-degree conduction mode of inverter. Since we know already the operation of inverter, we have a little bit confusion in plotting the waveform of 180-degree conduction mode in phase voltage and the line voltage. So this is the circuit diagram of three-phase PWM inverter. Now let us take the 180-degree conduction. So here you can see 6 switches, 1, 3, 5, 4, 6, 2. So it is numbered in the sequence in which it is triggered, in which it is turned on. So here you can see 6 switches, and here we have a star connected load, 3-phase loads A, B, C. So here we can see the gate pulse of each device, and then we can move on to the plotting of waveform, phase voltage waveform of 180-degree conduction. So here you can see the gate pulses from 1 to 6, G1 to G6. Let me take the first switch Q1, which is conducting for, and it is named as 180-degree conduction because each and every switch will be conducting for a period of 180. That's why it is termed as 180-degree conduction. So here you can see each switch will be conducting for 180 degree, and in 120 degree each switch will be conducting for 120 degree. So here I can see that first switch, it starts from 0, it is going to conduct for 180 degree, and the interval between each and every switch will be 60. That is, once the switch 1 is turned on, after 60 degree second will be turned, and after 60 degree third one will be turned on, and after 60 degree fourth one. Like that it goes on up to 6 switches. Again the cycle will start. And here you can see once the switch is turned on, it will be turned on for a period of 180. So here when you see the fifth switch, it is turned on for 180 degree here. So before that it should be turned off. For the previous 180 degree it should be turned off, and before that it should be turned on. So here you can see the gating pulses of all the 6 switches for a period of 2 pi, that is 360 degree. So let me take the first mode, that is where you can see at the first 60 degree my switches 1, 5 and 6 are conducting. So my switches 1, 5 and 6 are conducting, and in this 180 degree conduction mode you can see that 3 switches will be conducting at a time. So let me take the first mode, that is where 3 switches are conducting at a time. 1, 5 and 6. 1, 5 and 6, and here you can see the circuit diagram. So let me take that the switches switch 1, 5 and 6 are conducting. So when switch 1 is turned on, this A phase will be connected to positive of the supply, and when the switch 5 is turned on, this C phase is also connected to the positive of the supply, and when switch 6 is turned on, this B phase is connected to the negative of the supply, and that is what indicator here. So here you can see A phase and C phase both are connected to the positive of the supply, and B phase is connected to the negative of the supply. So here you can see when switch 1 is turned on, it makes the A phase to connect it to positive of the supply. Similarly 5 makes to connect it to the positive of the supply, and 6th switch when it is turned on, which is already on, so makes this B phase to connect it to the negative of the supply. So that I can have my equivalent circuit to be like this. And here from this you can calculate the things, that is here the equivalent resistance of these two will be R by 2, and the total equivalent resistance will be R by 2 plus R. The equivalent resistance of this will be, since these two resistors are connected in parallel, so I have R by 2, and the total resistance of this circuit will be R plus R by 2, so the equivalent resistance will be 3R by 2. And similarly, if I want to calculate the current I1 here, total I is nothing but V by R equivalent, so Vs by R equivalent is 3R by 2, so it becomes 2Vs by 3R. And now I want to find out the voltage across A phase, B phase, C phase and B phase. See, the voltage across VAN and VCN are same, so therefore VAN equal to VCN equals to current I into the equivalent resistance. Current I, the flowing current will be I1, and the equivalent resistance here is R by 2. So here you can substitute the values Here you can substitute the values where I1 current, value of I1 current is 2 Vs by 3R into R by 2. So therefore this R and R goes off, 2 and 2 goes off. I am getting Vs by 3. Similarly, you can calculate for VBN. Since the direction is reversed here, for B phase the current direction, since it is connected to negative polarity, the current should be minus I1 and the resistance of the B phase is R. So therefore it is R. So minus 2 Vs by 3. Again, since this I1 current, you can substitute the I1 current to be 2 Vs by 3 into 3R into R. So R and R goes off, I will be getting minus 2 Vs by 3. So this is how we calculate AN, VAN, VBN and VCN. Similarly, you can also calculate for the second mode. So when you take the second mode, again in the second mode, that is in second 60 degree, my switches 1, 2 and 6 are conducting. So therefore my equivalent circuit will be like this. When switches 1, 2 and 6 are conducting, my B phase and C phase are connected to negative of the supply and A phase is connected to the positive. Again the equivalent resistance will be R by 2 and I2 will be, that is the current flowing in the circuit will be V by R equivalent, that is 2 Vs by 3R. So this is how you can calculate your VAN, VBN, VCN, and you can see that in mode 1 and 2 we are getting our VAN, VBN, VCN to be like this, and based on that you can plot the waveform. For the first mode, that is for the first mode, this is my first mode, where for the first mode VAN, VCN is Vs by 3. So here you can see VAN, VCN is Vs by 3, and my VBN is minus 2 Vs by 3, so therefore here you can see my VBN is minus 2 Vs by 3. Similarly, for mode 2, again when you take it for mode 2, in mode 2 VAN is 2 Vs by 3, so therefore I can see VAN to be 2 Vs by 3, and for mode 2 VBN and VCN are minus Vs by 3. So here it is minus Vs by 3 minus. This is how you can calculate for all the 6 modes, each of 60 degree, and you can plot the phase voltages. And from this you can also calculate the line voltage, where line voltage VAB equals to VAN minus VBN minus VAN. This is how you can calculate your phase voltages and line voltages. Thank you.